Today's topic is from electronics subject. So under electronics subject, this is the topic which is called operational amplifier. Actually, what do you mean by amplifier? Amplifier, suppose if we give a weak signal of input signal, if this is an input signal, the output going to be a very high magnitude. We'll get a raised of output, very high magnitude. So this is an amplifier. We can say it as an amplifier. What is operational amplifier? Operational amplifier is it can do mathematical operation, arithmetic operations like subtraction, addition, multiplication, summing, differential, all called as operational amplifier. The output can, the magnitude can be raised as well as the polarity can be changed. Electronics, we have different applications. It can be used in power electronic, power converters, control drives, telecommunications. In many applications, we use electronics. In those electronic circuits, we have operational amplifiers. So operational amplifier, in short, it is called as op-amp. Is also is an IC. IC is integrated circuit. It is fabricated as a dual inline package, DIP. So what do you mean by IC is several components are present in a single chip. Can be passive and active devices which are present in a single chip. That is an IC. So that does multiple functions. That is an IC. So best example for analog IC is operational amplifier. For a digital ICs, we can take examples as flip-flops. So that computer can store and give the output like bits, zeros and ones. That is digital ICs. So this is analog ICs. So which is used in many power electronics applications. So we must know what for this and how it works, what are the types of operational amplifier, what are the characteristics of amplifier, advantages of amplifiers. So that about that simple introduction we will see from this operational amplifier. So as I said, it performs various linear, non-linear and mathematical operation. It can operate both with AC and DC signals. So short form is op-amp. Op-amp or operational amplifier is the backbone of analog electronics and output of many applications such as summing amplifier, differential, instrumentation. Op-amps can also be used as integrated, which is a very useful circuit in analog related application. So we can produce different types of signals also. Whatever signal is required, the type of signals also we can produce from this operational amplifier. The term is the magnitude is raised as well as the polarity can be changed. That is the op-amp. Operational amplifier have developed from circuit designed for the early analog computers where they were used for mathematical operation such as adding and subtracting. They are widely used in integrated circuit form where they are available in single or multiple amplifier package and often incorporated into complex integrated circuit for specific applications. Next up, we'll see the operational amplifier is named as IC-741. So we must know what is IC-741, why it is named as IC-741. So that we will see down below. So this is IC-741 op-amp. The pin number is IC-741. Why it is called as IC-741? What stands for this 7, 4 and 1? Actually, it is an 8-pin IC, dual inline package DIP. It represented as 7. 7 means the 7 pins are working pins. The 8th pin is not connected. Is NC, not connected. So they have mentioned here as 7. Next one is 4. The 4 represents the number of inputs to the op-amp. So first one is inverting input. So this is one input, inverting input. The second one is, the third pin is called as non-inverting input. And the 7th pin is called as plus power. And the 4th pin is called minus VCC. So these are 4 inputs. So that's why it is represented here as 4. And next is 1. What do you mean by 1 here? Is 1 is the output. Op amp is having a single output like this. Number 6 is called as an output pin. That's why it is named as 741 operational amplifier. So whenever the question is asked about the pin configuration about IC741, must draw the diagram, must represent the pin details like this. What is the input pins? Input pins are inverting pin number 2 and non-inverting pin number 3, and pin number 4 is power, minus power, and pin number 7 is plus VCC, and pin number 6 is output. So these are the simple representation of IC741. Now we will see what are the types of op amps. Simple types, I will say. I'm not making it more complicated. Simple one only we are seeing from this topic. And after types, we will see what is the advantages and characteristics of IC. So those things is also asked from this portion. So inverting operational amplifier. The first type is called as inverting operational amplifier. In the inverting operational amplifier, the signal is applied at the inverting input. So they will apply the signal in the inverting input, and the non-inverting input is connected to the ground. In this type of amplifier, the output is 180-degree out of phase of the input. So what do you mean by this is, I'll scroll down. This is inverting op amp. So in this inverting op amp, the input is supplied to the inverting pin. The inverting pin is minus pin. So the input is given here. So when the input is given to the inverting pin, the output will be 180-degree out of phase. It will be inversion. Suppose we are giving input like this, the output will be inverting and it will be amplified also. Input is given in inverting pin, and the non-inverting pin will be grounded. Inversion is minus, non-inversion is plus. The plus will be grounded. So this is called inverting op amp. So what do you mean by inverting op amp? Is input V in is given to the inverting point, that is in the minus pin it is given, and this is feedback resistor. This feedback resistor, it can be again feedback through this resistor, and the plus pin is called as the non-inverting pin, that is grounded now. So this is what, and it is an high gain amplifier. Op amps are high gain amplifier. Now we will see what is the output equation of this op amp. So we can expect some problems also. They will give what is V in, what is V out. We have to find out what is the gain of the system, or they will give what is RF feedback resistor. So we have to find out the unknown components from the formula. So we will scroll down to see what is the formula. So the formula of inverting input is gain. A is called as gain. Any gain, we will say that output by input. V out by V in is equal to minus RF by RN. Feedback resistor RF divided by input resistance RN, minus RF by RN. This is the formula for inverting operational amplifier. The next type is called as non-inverting operational amplifier. So non-inversion is plus. It is not going to get inverted. That is non-inversion. So what do you mean by non-inversion? The input is given in plus. The input is given in plus. The output will not be changed. It will not be the polarity will not be changed, but the magnitude will be changed. We cannot change the polarity, but the magnitude will be changed. That is called as non-inverting operational amplifier. And your inverting terminal will be grounded down. The inverting pin will be grounded down. And this is the feedback resistor. So this is feedback for this. So this formula for non-inversion is gain is equal to output by input, and that is equal to 1 plus RF by RN. So this is the formula for non-inversion operational amplifier. Next type we will see what is. Before next type we will see what are the materials I have made for non-inverting operational amplifier. As I said, when the signal is applied at the non-inverting input, the resulting circuit is known as non-inverting op-amp. In this amplifier, the output is exactly in phase. There is no out of phase, the same phase. When a positive voltage is applied to the circuit, the output will also be positive. There will not be any change in the polarity that I have already mentioned. By assuming the op-amp is ideal, then concept of virtual short can be applied. So the voltage at the inverting and non-inverting terminal is equal. So this is about the non-inverting operational amplifier. Next one is called as integrated circuit. In integrated circuit, if they give input signal in this form, the output will be in a triangular form. So there is a signal generation. We can change the signals also. Whatever signal is required for different application, we can use it, this operational amplifier. Operational amplifier is also used as a comparator circuit. If you see this control systems, many control application automation systems, they use this comparator with reference input and what is the measurement of the sensor, reference with the sensor measurement, that will be compared. So it can be used as a comparator also. Here we see it as an integrated circuit. So the basic operational amplifier integrated circuit op-amp is the capacitor. The capacitor is placed between the inverting input and the output. There is a resistor from the inverting input to the circuit input. A resistance and capacitance is connected. When we apply a signal to the inverting input, the output produces the reverse of the output produced is a CR integrated network. The output which is produced is an integrated output. So this is uses like this type of signals. It's like pulse form, and that is going to be converted in like a triangular form of output. So this is called as integrated circuit. And a simple op-amp configuration consists of two resistors. Normally, simply it will be two resistors, which creates a feedback path, one resistor. In the case of integrated amplifier, the feedback resistor is being replaced with a capacitor. So normally we had a feedback resistor in inverting and non-inverting op-amp. But here we have a capacitor circuit. So what is the integrator equation is V out is equal to minus integration of 0 to T V in RC by dt plus C. This is the formula for the integrated equation. Next is differentiator. The differentiated op-amp consists of input capacitor and the feedback resistor. This is CR network circuit. So as shown in the figure, a connection of capacitor in series with the input voltage source has been made. So capacitor is being made with the input voltage source. The input capacitor C1 is initially uncharged and hence operate as an open circuit. So it is not charged. The non-inverting terminal of the amplifier is connected to the ground. The non-inverting is connected to the ground, whereas the inverting input terminal is through the negative feedback resistor RF, and that is connected to the output terminal. So we have the circuit connection for the differentiated circuit, and the circuit, how it is connected, is being explained in this paragraph. So instead of input voltage, we are giving input voltage through a capacitor, and the capacitor is in series with the input, and the input capacitor is initially it will be not charged, it is uncharged, and so operate as an open circuit only. So the non-inverting terminal of the op-amp, as usual, this non-inverting is being here, it is grounded in the differentiated circuit, whereas the inverting input terminal is through the negative feedback. So the feedback circuit we have here is feedback resistor RF is connected to the output terminal. The general formula of this output is equal to minus CR dV in by dt. So dV in by dt. This is the general formula for differentiated circuits. Next we have is summing amplifier. A summing amplifier is adding of different voltage inputs. So different voltages are given to one pin. That is summing. We have two types. One is non-inverting summing and another one is inverting summing amplifier. So here only one I have shown about the summing amplifier. The most commonly used summing amplifier is an extended version of inverting amplifier configuration. So this is inversion. In inversions, we have given three inputs here. So these three inputs is given through three resistance, and this is for summing amplifier. While the non-inverting input terminal is connected to the ground. Due to this configuration, the output of voltage adder circuit is out of phase by 180 degrees. So all the voltages will be added and the output will be amplified output with out of phase of 180 degree. The output will be changed. So that is called as a summer amplifier. So next one is what are the advantages of op-amp? So the advantages of op-amp is operational amplifier circuit can be made to perform both integration and differentiation. The circuit can be modified to give various applications. So as I have already said, it is used for different application. Electronics is used for power converters, power electronics. Power electronics is a key for generation, distribution, and production also. So for controlling of motor control circuit, control drives, everywhere we use electronics. So in that many circuits, operational amplifier applications are used. So as I said, it is a good example for analog ICs also. So it does multiple functions. It can do multiple functions and it can produce signal generators. So the output voltage is very high gain, that is almost 100 times greater than the input voltage. So it can produce nearly 100 times greater than the input voltage. And applications of op-amp is integrated is an important part of an instrumentation and it is used in ramp generation. In ramp is one form of signal. So integrated, what it is producing at the output is an important part of instrumentation. So that is used for ramp generation also. In function generator, integrated circuit is used for triangular wave. So it is used for wave shaping circuit, different kind of charge amplifiers. It is used in analog computers where integration is needed to be done using analog circuit. Integration circuit is also widely used in analog to the digital converters also. Different sensors also use an integrator to reproduce useful outputs. So these are the applications of op-amp. So this next one is called characteristics of op-amp. This is also very important. Characteristics of op-amp is the value of the input impedance is high. Input impedance is high and the output impedance is low. The output impedance is low. The frequency range of the amplifying signal will be from 0 to 1 megahertz. The value of the output voltage and the current are low. So, and it is an high gain amplifier. As I have already said, the output is 100 times higher than the input. So this is called as a high gain amplifier. So the gain of the voltage is very high. So these are the points for important points for the characteristics, technical points for the operational amplifiers. So these basics we have discussed. The remaining will be seen in the class hours. So I want to solve some problems with the summing amplifiers so that we will discuss it. I will give the formula and problems to solve the summing and the differential amplifiers. So one or two types has to be seen in the next session. Thank you all.